Hi everyone. We're going to do a little note taking today, so have some paper out and be ready to write some things down about how to take good observations. You should all have your textbooks by now, I'm hoping. And here we go. Chapter 1 starts off with a little the section 3 in chapter 1. So if you look in the top left hand corner here, the 1.3 means chapter 1 section 3, and that last section talks about thinking like a scientist. We'll go back and look at the beginning of the chapter next maybe tomorrow. So most of you probably know from biology that the green stuff on an orange that's been in your refrigerator at the back for too long is actually useful. Alexander Fleming noticed that bacteria he was trying to study way back in 1928 wouldn't grow if this green stuff was on the agar plates, and it turned out that he realized that this could be useful, and he ended up isolating penicillin. Now penicillin's been a lifesaver, godsend for a lot of people. Of course, there are some of us that are allergic to it, but it really changed medical history and saved a lot of lives. All right, here's a funny word, alchemy. And what in the heck is alchemy? Well, alchemists were people that worked in the Middle Ages trying to figure out what the heck matter was made of and how to change it. So they developed a lot of the equipment and techniques that we use still today in a scientific chemistry classroom and chemistry lab. This is a wood cutting from a long time ago, and it looks kind of freaky. The people look kind of crazy and messed up. And that's probably because a lot of alchemists, like this guy down here on the floor, were messing around with stuff that was really bad for them. Hopefully they're not trying to harm children up here, but at any rate, they were messing with things like mercury and other heavy metals and other toxic chemicals that sometimes made them a little off. But we're really glad that they did the work they did. I'm not sure if they're putting someone in the fire there or not. But at any rate, you can look at the picture in your book. So what kind of things did they do? They developed processes that helped us separate and purify mixtures and get individual chemicals. They developed equipment like a mortar and pestle. Some of you might have it, and this is a picture of spices, and some of you might have one of these in your kitchen like I do to grind whole spices. They helped us make beakers and flasks and tongs and funnels and all sorts of things, and we will go over all the names of equipment later next week. So Antoine Lavoisier is credited with being the father of modern chemistry. In the 1700s, he was a French nobleman. He had enough money to make his own laboratory at his house. This is his wife, who ended up translating his work in French into English. You might recognize this year as an important year in the history of France. If you haven't studied it yet, you will. And unfortunately for all of us, Antoine Lavoisier was guillotined during the French Revolution. But before he lost his head, he helped us create true scientific observations and good measurement. That's a really big thing. This is a replication of his lab in Paris. He actually, in the 1700s, had a balance that could measure out to not the tenths, hundredths, thousandths, but 10,000ths of a gram. Our balances, our electronic balances that we use in class only go to the hundredths place, kind of like pennies out of a dollar. He also did experimentation to prove that oxygen was required for burning and all sorts of other things. He was pretty amazing. But obviously, you couldn't do science, just like you couldn't go to college unless you were super rich in his day. All right, so what are observations? Observations are direct gathering information, and you use all your senses to do it. You can use equipment. There's nothing wrong with using equipment. You just have to know how to use it properly. The other thing with observations that I want to emphasize is that an observation is one that any other qualified individual would be able to make identical to yours. So, one of the problems we have as human beings is we make observations and we interpret them. That can be really dangerous. Okay, so again, an observation is a direct gathering of information. An interpretation, we're adding an explanation or meaning or importance, like all the fires are God's way of telling us he's mad at us, which of course is not true. Another example would be you smile and you wave at someone. Like you're in the mall, if we ever get back to campus again, and you wave and they laugh. You see them laughing. And of course, what do we all assume? Because we're all assuming everybody's thinking about your me all the time. We assume they're laughing at us. Could be that they heard something someone said behind them, and it could be they saw something behind us. We don't know, but we usually get our feelings hurt if that happens. So I like to say, just the facts, ma'am. That was from an old detective TV show. Don't give me all the fluff. Don't give me all the likes and dislikes. Just tell me the facts. All right? So a good observation is going to use your senses, all of them, except in chemistry we don't use taste. Observations will lead to questions. The sky is blue. Mommy, why is the sky blue? We use them to make hypotheses, those questions. I think the sky is blue because the fairies put blue sparkles up there. You take observations before, during, and after. I just shorten that up because I don't like writing words. BDA, before, during, and after. Before you start, during what's the exciting part, and after it's all done, in quotes. Make them short and sweet and complete. So a little cutesy phrase to make it, don't get all fluffy and cute and Englishy on me. Also, keep in mind that observations are not going to be graded for spelling or grammar. You're trying to jot down as much as you possibly can, as quickly as you can. So, two big important words: objective, subjective. Objective observations, again, are what we want. We want any competent individual to make the same observations with the same equipment. Subjective means you're putting some sort of feelings, opinions, biases into what you've observed. Temperature should be a number, okay? You're going to say it's hot, you're going to say it's cold, you're going to say it's warm, and I'm going to say compared to what? You can say the temperature increased. You could say warmer than room temperature. That helps give us an evaluation. But lots of things could be warmer than an ice cube, for example. Mass, we're going to measure in kilograms. We'll talk about that. Heavy or light, something's really heavy, something's really light. A lot of times when we say that, we're meaning something to do with density. Size, M is for meters. You might say something's humongous, something's super tiny. Well, it might be a humongous red blood cell, or it might be a really tiny elephant. You have to be careful, okay? Time is measured in seconds, not it took forever, okay? Give us a quantity. The odor of a skunk. Every year I ask, and usually there's someone in the room that likes the smell of skunk. I'm sorry for you. But also sometimes lots of people like the smell of gasoline. That's a really bad thing. Don't smell gasoline. It's bad for your brain. It's carcinogenic. It causes cancer. Don't breathe gasoline fumes. At any rate, some people like the smell of skunk. Most of us would say it stinks. You should say it has the odor of a skunk. That would be an objective observation. And then the other person can put their subjective feelings about it into their own brain. All right, another thing, 2 words. These are hard to get straight, so pay attention. Measurements are quantitative. They have quantities. They have numbers. Anytime we do stuff in science, we really want to have numbers. Qualitative are qualities in words, okay? Sometimes they're feelings. Sometimes the best you can do is give a qualitative definition. For example, blue. Turns out, you can say sky blue, you can say navy blue, you can say dark blue, pale blue. There's all different ways you can qualify your qualitative observation. Scientists can actually put numbers to the wavelengths of light and give an exact numerical value for the wavelength of each color of blue. Your eyeballs can't do that on their own, and most of us don't have a spectroscope hanging out in our back pocket. So you qualify things, that's okay. It's not the end of the world to have qualitative observations. You just want to beef them up a little bit, right? There's all different colors of red. There's candy apple red. There's watermelon red. There's different reds. So you have to kind of add a little bit more. Again, something's big or small. Give me compared to what? It's better if you have numbers with kilograms and meters, for example. Something's fast or slow. Compared to what? Okay, a 57.3 it might be a really fast time for a certain kind of running event. You can estimate, you can compare to other things, that's okay. Your thumb is about 1 inch across, the thumbnail. Your pinky is about a centimeter across, give or take. Measuring from your nose to the end of your middle finger, holding your arm straight out to the left, is about 1 meter. Those of you that do knitting or sewing know that that's close to a yard. Another thing that people do to try and get perspective, like geologists, they'll put coins or their rock hammers in the pictures that they take, so you get a perspective. And again, the word approximately is your friend. You don't have to have exact measurements, you don't have to have a measuring device, but give the person a comparison so they can have a clue of what you're looking at. So, best observations, take them before, during, and after the event, the exciting part. Be objective, be quantitative, make them short and sweet and complete, get down everything you possibly can as fast as you possibly can. Don't add any fluff, and you'll be all set. So here's my cute little abbreviations. Before, during, after, objective, quantitative, that means numbers, quantities, short, sweet, and complete. Now, again, there's nothing wrong with making qualitative observations, just add to them, compare them to something else. All right, so what I'd like you to do tonight is to sort your observations into those categories. There will be some overlap, so here's the deal. You're going to be objective if you're quantitative. You're going to probably be more subjective when you're making qualitative. If you said your candle smells good, okay, that's a subjective observation, but it is words, so they're kind of in the same categories, right? So we can just make 2 separate categories, objective and quantitative, subjective and qualitative. If you want to try and sort them into 4, you can, but just go ahead and make them into 2. And then the last piece to this, at the bottom of your notes or on your sorted observations, find another candle, a different one than the one you used the other day, and observe for, let's just say, 3 minutes. You've already seen a really extensive observation. Just go ahead and observe for 3 minutes. And that, my dears, is it. I hope you have a good rest of your